Hello everyone and welcome back to my channel. This is the continuation video from the last video of message traffic generation that we did earlier. In this video we are going to use the same topology but to simulate the WAN model. In this video we are going to learn how to use the wide area network cloud and subnet objects available in COMNET to model wide area networks. We are also going to learn how to use the WAN cloud, subnet, and proper routing settings to design a wide area network model in COMNET. Now let's see what is a WAN cloud means. In this left side you can see this cloud symbol. This is a WAN cloud. The WAN cloud provides an abstract method of modeling wide area networks that provides an alternative to model a WAN explicitly using different network device nodes and point-to-point links. The cloud's internal structure is going to be defined using access links and virtual circuits. In reality, wide area network is the collection of multiple LANs connected through different routers. But in COMNET, we are going to build the internal structure of WAN cloud using the access link and the virtual circuit. These are the two links that we are going to use to make the internal structure of wide area network. The access link, which is this one, the access link provides the point of presence to the WAN cloud. A virtual circuit, which is this one, is a means of transporting data over a packet-switched network in such a way that it appears as though there is a dedicated physical link between the source and the destination end system of this model. A WAN cloud may be created either by using the palette or the library menu. Simply we can use this button to create a WAN cloud. Now the next option is the Subnet. This is the Subnet menu. The Subnet menu provides two functions within the COMNET. The first is the method of managing the display of a large network, and the second is providing a method to allow different routing protocols to be used in different portions of the network model. Routing protocols are used to define the path for the packets in the network. A subnet can be created by choosing the subnet icon from the toolbar, which is this option. Packet routing protocols. As packet traverse on the network, defined in the backbone and subnet views created, routing decisions must be made for a packet to reach its destination. The routing protocol which are built into COMNET includes IGRP, extended IGRP, link state shortest path first, RIP minimum hop, minimum penalty, shortest measured delay, user-defined routing tables, OSPF standard cost matrix. These are different routing protocols which can be used inside the COMNET. Different routing protocols may be defined for the backbone network and for each subnet. Routing protocols are set for the backbone network by choosing the backbone properties option from the defined menu. Now let's look at the scenario. The scenario is the scenario which we used earlier on the tutorial 3, message traffic generation. Now in this scenario, on the same context, we are going to assume that the two departments which were Ethernet network and one was on token ring network. Now we are going to break that departments into London department and Liverpool. Each department will have its own LAN, and those two LANs will be connected through Cisco 7200 routers via WAN tunnel. The tunnel from the LAN to WAN and the link in the WAN have a transmission rate of 256 kilobit per second. And the tunnel from the WAN to the LAN has a transmission rate of 512 kilobit per second. Now we are going to rebuild the model from the earlier model. So now let's go to creating the London LAN for London office. The local area network topology will be created within a subnet called London LAN. So we are going to break our LAN and put it inside the London LAN. The internal structure of the London LAN should appear similar to this figure. So this is the step-by-step description of today's tutorial 4, simulating the WAN model. First step, open the model created in tutorial 3 and save as a new model called WAN. Save it. Create a subnet using the toolbar. Change the name of the subnet to London LAN and place it on the top of left. This is the subnet option. Click on it and place it right here. And right click, go to properties and give the name as London LAN. Click OK. Now select all objects on the left side up to the router excluding the London LAN subnet. Copy selected objects by using copy function from the edit menu. Go to edit, select copy. Enter the London LAN subnet by double clicking mouse on the subnet and paste selected objects in the center of the subnet work area by using the paste function from the edit menu. So we have to go to this London LAN and go to edit and click paste. Select the position and click on it. Just left click, one click. Now we have to change the name of network device from router to London router and use Cisco 7200 as its parameter. Double click on this router. Change the name of this router to London router. And change this parameter to Cisco 7200. Let's search for Cisco 7200 router. Copy this and select done. Now the parameter is Cisco 7200. Click OK. Now let's go to 7 number. Create two message source, connect them to the London router and change the name of the message source to London EXT routing and London INT routing. So this is going to be the London EXT routing. Click OK. And this is going to be the London INT routing. Click OK. So what is the meaning of London EXT routing and London INT routing? London EXT routing is used for sending the file request message from London LAN to Liverpool router because the London LAN contains email server and the Liverpool LAN contains the file server. So if any of the email request has to come, then it should have to come to the London LAN, and if any of the file request has to come, it has to go to Liverpool LAN. London INT routing is used for receiving the email request message from Liverpool LAN and send it to this email server inside the London LAN. So now we have to create an access point and link it to the London router. This is the access point. Select it and come to the workspace. Select the position and click on it. This is the access point. Now this access point is going to link this London LAN with the WAN connection. Connect the London router with the access point. Complete London LAN and the structure of the LAN should appear like the topology shown in the figure 1. Figure 1, and this is going to be our London office. Let's add our text on the top. This is our London office. Return main work area by double clicking mouse. So if we click on any of the blank spaces, we are going to return to our main work area. This is the London LAN that we have made just now. Now the second part is to create the Liverpool LAN for Liverpool office. Another local area network topology will be created within a subnet called Liverpool LAN. The internal structure of the Liverpool LAN should appear like the topology shown in figure 2 upon completion of building the LAN model. So this is going to be the internal structure of our Liverpool office. Now on the 11 number, create a subnet using the toolbar. Change the name of the subnet to Liverpool LAN and place it on the top right. This is the subnet. Click on it and put it right here. Right click on the subnet and go to properties. Change the name to Liverpool LAN and select OK. Now we have to go to 12 number. Select all objects on the right side from the router excluding the Liverpool LAN subnet. Including the router. Copy selected objects by using copy function from the edit menu. Go to edit and copy. Enter the Liverpool LAN subnet by double clicking mouse on the subnet and paste selected objects in the center of the subnet work area by using paste function from the edit menu. Now after we copied this portion, go to the Liverpool LAN, double click it and go to edit and select paste and choose the location. Now in the 15 number, we have to change the name of network device from router to Liverpool router and use Cisco 7200 as its parameter. Go to router, double click the router, change the name to Liverpool router and the parameter should be Cisco 7200. Select OK. Also we have to create two message source, connect them to the Liverpool router and change the name of the message source to Liverpool EXT routing and Liverpool INT routing. So similarly select this message source, put it right here, select another one, put it right here and change their name to Liverpool EXT routing. Select OK and select this message, right click properties and change the name to Liverpool INT routing and connect them. This Liverpool EXT routing is responsible for receiving the email and email check messages from inside the Liverpool office and forward it to the London LAN London router, and then the London LAN London router is going to forward that message to the email server. Whereas the Liverpool INT routing, it is going to receive the message from the London EXT routing destination, which has the file request messages, and the file request messages from the London LAN is going to be forwarded to the file server inside the Liverpool LAN by this Liverpool ENT routing. So generally Liverpool EXT routing is responsible for sending the messages from inside the LAN to the London LAN, and Liverpool INT routing is responsible for forwarding the incoming messages from London LAN to the Liverpool LAN. Now let's go to 17 number. Create an access point and link it to the Liverpool router. This is the access point. Click on it and click on the workspace. Now connect it with the Liverpool router. Coming back to 18 number, complete Liverpool LAN and structure of the LAN should appear like the topology shown in figure 2. If we go up, this is our figure 2 and our LAN looks like figure 2. Let us add a text for Liverpool office. Okay. Return main work area by double clicking mouse. Double click on any of the blank space. Now modeling the WAN using a WAN Cloud. The following steps outline the method for modeling the WAN using a WAN Cloud. The backbone view of the model should look like figure 3 upon completion. This is the view of WAN Cloud and Subnet. Now go to 20 number. Clear all objects from the previous models by using clear functions from the edit menu. So select all of the components except London LAN and Liverpool LAN and clear them. Now go to 21 number. Create a WAN cloud and place it in the work area. This is the WAN cloud. Click on it and place it on your work area. Change the name it to WAN Cloud. Select OK. Now on the 22 number, enter the WAN Cloud by double clicking mouse on the WAN Cloud. Double click on WAN Cloud. Now we are inside the WAN Cloud internal architecture. In the real scenario, the WAN Cloud is made up of multiple LANs and multiple routers. But in the COMNET, WAN Cloud is made up of virtual circuits and access links. These are the two links, that is point-to-point link or also called as access link, WAN link or also called as virtual circuit. Now we have to define the components or parameters for these links. Point-to-point link is a point of presence link which connects the LAN to WAN, whereas virtual circuits connects multiple access links. Virtual circuits makes the actual path that is used for the transmission of packets inside the WAN cloud architecture. Now if we see on the 23 number, from the define menu, choose the link parameters, cloud components, cloud access parameters option. Edit the fields in the cloud access link parameters window to the values shown in the following list. Basically, we are now going to configure the parameters used for access link or also called as point-to-point link. So go to define menu, link parameters, go to cloud components, go to cloud access parameters and click on edit. Give the name 256/512K access. Number of circuit is 1. Entry bandwidth is 256. Exit bandwidth is 512. Entry and exit bandwidth or circuit specifies the transmission rate to and from a node and the WAN cloud. As we saw on earlier screen, the WAN tunnel has an entry bandwidth of 256 kilobit per second and an exit bandwidth of 512 kilobit per second. So this is configured right here on the access link. Now exit buffer, go to exit buffer, uncheck this use unlimited buffer and give the buffer size as 16834. What does this exit buffer means? The exit or egress buffer controls the buffering that is available at the input side of the exit part of the access link. An access link may be connected to several virtual circuits that deliver frames at the same time, in which case the frames may have to queue to wait for the earlier frames to get transmitted. This buffer is sorted by priority of the frames. The method for determining frame priority is set in the cloud parameter set. Here, if the buffer value exceeds 16,834, then the buffer will block incoming frame. This parameter is going to be used on access link, also called as point-to-point link. Now click on Return, select OK, select Done. Now we will select the parameters for virtual circuits. From the Define menu, choose the link parameters, cloud components and cloud VC parameters. So this is right here, cloud VC parameters. So select it and click on Add. Give the name as 256K circuit. Committed information rate is 256. The maximum throughput rate per virtual circuit. Committed information rate is expressed in units of kilobits per second. Generally, it also defines the bandwidth of the virtual circuit, which carries 256 kilobit per second. The next one is committed burst size. It should be 256. The maximum number of bits which are committed or guaranteed to be transmitted over a burst interval if received continuously by the switch. Here, the burst terms means that the condition where multiple number of messages tries to come at once. Access burst size is 2. Access burst size represents an additional number of bits above the burst size which will be allowed to be transmitted if the bandwidth is available on the network. Click OK. Click Done. Now go to 25 number. Create an access link or point-to-point link within the WAN cloud and edit the following fields in the access link window. So here is the access link, or also called as point-to-point link. Click on it and add it right here. Right click, go to properties and change the name to London access. The parameter should be 256.512K access. Create another clone of London access and rename the link to Liverpool access. Go to this London access, right click, go to clone, select number of clone 1, click OK and put it right here. Give the name as Liverpool access. Now let's go to 27 number. Create 2 access points in the WAN cloud and attach one to each of the access link. Select the access point, put it right here. Select another access point, put it right here, and let's connect them. Now go to 28 number. Create a virtual circuit in the WAN cloud. This is the virtual circuit. Click on it and put it right here. Edit the fields for this circuit to the values shown in the following list. Now select this virtual circuit, right click, go to properties and give the name as London to Liverpool. Type is frame relay virtual circuit and the parameter should be 256K circuit. Select OK. Now go to 29 number. Create another clone of London to Liverpool and rename the virtual circuit as Liverpool to London. Select this virtual circuit, right click, go to clone, select WAN number, click OK, put it right here, right click, go to properties and give the name to Liverpool to London. Select OK. Now connect the virtual circuit to the access link as following figure number 4. So now let's connect this virtual circuit with the access link as shown in this figure. Now this London to Liverpool is going to be the transmission path for London to Liverpool, whereas this Liverpool to London virtual circuit will be the transmission path from Liverpool to London. Now we have completed up to 30 number. Let's go to 31 number. Return main work area by double clicking the mouse. Attach each of the access points of the WAN cloud to an access point on one subnet. It should appear like the topology shown in the figure 3. This is the figure 3. Now let's connect them as shown in the figure 3. We have completed up to 32 number. Now it's time to set the message destination and routing feature. In WAN model, message from a LAN will first transmit to local router, then to a remote router in another LAN, finally to the destination. It is very important to set message destination and routing properly in order to obtain accurate simulation results following step-by-step exercise which is given right here. We have the condition that the email server is on London LAN and file server is on Liverpool LAN. Go to exercise step number 33. Enter London LAN. Edit all email and email check message destination list to London LAN email server, because the email and the email check messages which is situated right here, they will have to now go to the London LAN email server as their destination. Now let's go and change the destination of all the email and email check. .34 number is completed. Go to 35 number. Edit the file request message destination list to London LAN.London router by selecting it from the destination list. File server is inside the Liverpool LAN. We are now currently inside the London LAN. So all the file request messages from London LAN first should go to the London router. After that, the routing process, which is the London EXT routing for this scenario, will decide where to forward the file request. Go to your file request message, go to destination, go to edit destination and select add and select London LAN.London router. Click OK. Select done. OK. Now go to 36 number. Edit the LAN voice message destination list to London LAN.EtherPC29 by selecting it from the destination list. Go to the LAN voice, destination, edit, add, London LAN.EtherPC29. OK, done, OK. Go to 37 number. Edit the London EXT routing parameters to the values shown in the following list. As I told earlier, London EXT routing is going to carry the message from inside the London LAN to the Liverpool LAN. So the received message will be the file request and the destination will be the Liverpool LAN.Liverpool router. Now go to London EXT routing. Schedule by should be received message. Edit received message should be file request. And the destination should be waited list. Click on edit, add Liverpool LAN dot Liverpool router. Okay, done. Okay. Now it's time to configure London INT routing, which is used for routing the incoming message to London LAN from Liverpool LAN. Select the London INT routing as instructed in 38 number. Open it. Scheduled by should be now received message, and edit received message list containing only the Liverpool LAN dot Liverpool ext routing. So the message which comes from Liverpool ext routing will now come to London INT routing, and it will be forwarded to the London LAN dot email server. That means the message which comes from the Liverpool ext routing to this London LAN, those messages will be the email request made from Liverpool LAN. So now go to edit received message, click on add and select Liverpool ext routing. Select OK. Done. Now the destination should be the London LAN email server. Waited list, edit, add London LAN dot email server. Click OK. Select done. Select OK. Now go to step number 39. Leave London LAN and enter Liverpool LAN. Go to 40 number. Edit all email and email check message destination list to Liverpool LAN dot Liverpool router, because the email server is situated on the London LAN, and if the email and email check message goes from the Liverpool, it has to first go to the Liverpool router. So go to your email message, go to destination, go to edit and select add and select Liverpool LAN dot Liverpool router. I have already selected. That's why it's already here. Click on done. Okay. And now repeat the same process for all email check messages. The destination, click on edit, add and select Liverpool LAN dot Liverpool router. Now go to 41 number. Edit the file request message destination list to Liverpool LAN dot file server, because the file server is situated inside the LAN, and this file request message destination will be the file server Liverpool LAN. Go to file request, go to destination, select edit, add and select Liverpool LAN dot file server. Click OK, click done, OK. Now go to 42 number. Edit the LAN voice message destination list to Liverpool LAN TRPC29 by selecting it from the destination list. Go to this LAN voice, go to the destination, click on edit and click on add and choose Liverpool LAN dot TRPC29. I have already configured this, so I'm going to click on done. Okay. Now let's move further. Edit the Liverpool ext routing parameters to the values shown in the following list. Now go to Liverpool ext routing. On scheduled by, click on receive message, and the received message will be the email and email check, because the email and email check message will be carried from Liverpool LAN to London LAN. So click on edit, select add, click on email, OK, again add, select email check, click on OK and done. Now go to the destination, and the destination will be the London LAN.London router. Waited list, edit, add London LAN.London router. OK, done. OK. Now it's time to edit the Liverpool INT routing as given parameters. Go to Liverpool INT routing. This is responsible for routing the incoming message into the Liverpool LAN. So the scheduled by will be the received message. The received message will be the message from London LAN.London ext routing. So select add and click London ext routing. Select OK, click done. And the destination will be the Liverpool LAN.file server. This means the London ext routing will carry the message of file request from the London LAN, and that will be now go to the destination, waited list and file server. Now let's go to 45 number, verify model. Go to simulate, click on verify model. You can see no verification errors detected. Now we need to set up the run parameters. Go to simulate, go to run parameters, and the warm-up length should be 120 seconds, number of replications should be 1, and replication length should be 3600. I have already told you the meaning of warm-up length, number of replication, and replication length in the first tutorial. If you have not watched the first and second tutorial, I'm going to link it on the I button on the top right corner. You can go and check it out first. Select OK. Now we need to select reports that we want the COMNET to generate for us. For that, go to report, go to select report, and double click on nodes. Turn this received message count on all and show group node in details. Click OK. Go to links, turn on this channel utilization and collision stat document, and now go to WAN clouds and turn on this frame delay by virtual circuit. I will explain about these reports later on. Frame delay on all, select OK, and frame count by virtual circuit on all, OK, and also access link stats on all, OK. This is basically the report selection for the access link and the virtual circuit that we have configured inside the WAN cloud. Now go to message plus response source and turn on message delay for all node report. Message delay for all node on all, OK. So click done. Now come back to your original WAN cloud and select and do run simulation. To run simulation, you can simply press F4 from the keyboard or go to simulate and click on start simulation. Click save. Simulation is running. The simulation has been now completed. Now it's time to check out the report. Go to report and select browse report. Stat1.rpt is your report file. Open it. Now the first report that we get is of the received message count in a WAN model. These are all the receivers. These are the number of counts that they received. These are the message name that they got during simulation process. It also contains all the group members of group node, so you get a very long list. As you can see, email servers received a bigger number of messages than individual PCs. These are the members of group node, so we get a long list. The next report is of channel utilization. The London LAN Ethernet is used up to 0.03%, and the Liverpool LAN token ring is used up to 0.0565%. The amount of frame delivered in the London LAN is 3431, and here on the token ring network is 4683, which is on Liverpool. I have already discussed about all these reports in very detail on the earlier video. If you have not watched it, go to the I button and watch it. The collision stat also we have already discussed about this. The link name is London LAN Ethernet. The access protocol is CSMA-CD. Collision episode is 849. Frames is 1698. These are the number of tries to resolve, number of deferrals, deferral delay, average standard deviation and maximum time, deferral queue size, multiple collision episode report. Now the new report for today's tutorial is the frame delay by virtual circuit. If you see, this frame delay by virtual circuit report presents statistics for the delay in frame and burst size for each virtual circuit in a WAN cloud. This frame delay statistics is for all the frames that the WAN cloud successfully delivers. Burst is the condition where multiple frames comes at once. The burst size is monitored for each frame that the virtual circuit accepts and captures its peak value. Now let's check out all the components inside this frame delay by virtual circuit report. This is the first column of frame delay, which is given in millisecond. The average standard deviation and maximum frame delay in millisecond, which is incurred by link layer frame on each WAN cloud. If we go right, there is a burst size column. That means the average and maximum burst size in kilobits of packets transmitted across this virtual circuit. Now the next report is of frame count by virtual circuit inside the WAN cloud. So frame count by virtual circuit is a report that gives you the measures for each virtual circuit in terms of number of frames that the virtual circuit accepted or dropped, and also the number of kilobits accepted or dropped. They are further divided into normal and discarded eligible frames. Here is the first option of cloud, which is the name of our WAN cloud. The first line of data in the report identifies the WAN cloud that includes following virtual circuit, which are London to Liverpool and Liverpool to London. It also lists the total number of kilobits that successfully transmitted through the cloud, that is 536. The general understanding of this report is that the name of the virtual circuit defined inside the WAN cloud is given right here first. For each virtual circuit, there are two rows of data. One is the frame and another one is the kilobit. For each row, there are separate counts for the normal frames and the discarded eligible frames were accepted and dropped both. In this count, frames that are dropped due to excess burst size will be counted as discarded frames. Also, the accepted frames may be dropped later on when they arrive at the exit buffer. The next report is of the access link stat report. Access link stat report gives the statistics for each access link inside the WAN cloud. For now, we have two access links. One is the London access and another one is the Liverpool access. For each access link, two rows are printed. First is the entry one and another one is for exit. Here, no buffer is modeled for the entry link. That's why it is showing not available. This is the name of the clouds, WAN cloud. access link is the name of access link inside the WAN cloud. The first column is the frame accepted. The second column is the frames dropped. Now what does this frame accepted column means? The number of frames accepted by the entry and exit link of the WAN cloud. For entry link, this count reflects the frame that found a path to the destination. If a frame arrives that must go to the destination, but it does not have any virtual circuit defined and the cloud does not allow the transmission through non-virtual circuit, then in that situation the frame is counted as dropped frame. Next one is the frames dropped column. The number of frames dropped by the entry and exit link of the WAN cloud. For exit link, the count reflects the number of frames accepted or blocked by the exit buffer. In case where a low priority frame is initially accepted by the buffer, but in the same situation a higher priority frame comes, then the low priority frame will be counted as being dropped and will not be accepted. Now let's move on to the right and see the buffer byte report. This is the maximum, average and standard deviation of the buffer size for entry and exit access link. This is the percent utilization of access link. The entry and the exit access link utilization in terms of percentage. The utilization is time averaged over the replication, where at each event the utilization is the number of busy circuit divided by the total number of circuit. And moving on further, we have the report of message plus response source, which has the origin, the message source name and the destination list. It has the number of messages assembled, the average, standard deviation and maximum time taken. If we see here, the timing is not that much bigger. The email server has higher time, but all the other timing is normal. So email server has the more messages to get to respond. Now moving further, we have the report for the message delivered inside the session which we created for the LAN voice. So the message assembled name is the LAN voice and the number of messages assembled were 3 between the London LAN Ether PC 1 to the London LAN Ether PC 9, because only the supervisor is responsible for sending the voicemail and the employee PCs will receive them. And similar is case for the Liverpool LAN. And the next is the session setup count. The number of sessions fixed in the London LAN were 3 and in Liverpool were 4. There were no any retried, blocked, disconnected or retarded sessions inside this session in both LAN. So this is the report that we get from the workshop 4. I hope you understood and this video was helpful for you to learn about the simulation of WAN model inside the COMNET. If you liked the video, hit the like button and subscribe to the channel. Thank you for watching. Have a good day. We will see you on the next video. Take care. Bye.